Hello students, today we are going to see error analysis. So whenever we perform any experiment, there can be various type of errors. So errors from the instrument, that is called instrumental errors. Errors done by the experimentalist, because if the experimentalist is not very experienced, he will do errors in the experiment. And there is another type of error, that is random error. These first two error, basically instrumental error and errors by the experimentalist, this first two error is also called as systematic errors. This is called as systematic errors. So instrumental error and errors by the experimentalist, that is your systematic errors, can be removed by detecting their cause. So detecting their cause means if the instrument has some error, you just remove that instrument and install a new one. Or if the experimentalist is not performing well experiment, you can replace that experimentalist and put another good experimentalist. Then your errors can be removed. But you cannot minimize the errors, the instrumental errors or errors by the experimentalist by large number of observation. That means you cannot take the average value and minimize the errors here. So systematic errors, two things you got. So it can be removed. Second one is it can't be minimized. It can't be minimized. For random errors, you cannot remove the random errors. It is always there in the experiment. But you can minimize the random errors by taking large number of measurements. You take large number of measurements, then your random errors will be going to minimize. So for random errors, we can write this can't be removed but can be minimized, right? Okay. Now we'll see the examples of the random errors. So random vary in temperature or pressure is called your random errors, or random vary in temperature or voltage also called your random errors. These are the basically examples of random errors, and lots of examples you can see for the random errors. So let's do this question. It is actually asked in NEET 2023. The errors in the measurement which arises due to unpredictable fluctuation in temperature and voltage. So unpredictable fluctuation in temperature and voltage, this is basically your random errors. Clear? This is basically your random errors. Because you see here we discuss, right? Random errors example are random vary in temperature, pressure, random vary in temperature and voltage. Similarly, you can say here this is the unpredictable fluctuation in temperature and voltage, so it will be your random errors. Okay. Now we'll see the measured value. So basically measured value means you basically measure this value by a measuring device. So measuring device means, let's say you are measuring length. For length you use scale, that is your meter scale, right? Or vernier caliper. Similarly, I can say for mass you use weighing balance you use, and also spring balance, right? You use for measuring the mass. Weighing machine or weighing balance you can say. Similarly, for time you use stopwatch, right? These are called measuring devices. Scale, weighing balance, stopwatch, all these are measuring devices. And in these measuring devices, you are taking the measured value. Let's say x1, x2, x3, x4, like xn. All these are measured value, right? All these are measured value. Then we will find out the actual value or true value. How we will find out actual value or true value? We will average out all this measured value, basically x1 plus x2 plus x3 plus x4, like that, divided by n. This will be your true value or actual value. If let's say you take 10 number of measured value, so 10 number of measured value, then for that true value will be how much? You will tell x1 plus x2 plus x10 divided by 10. Basically you are averaging out, right? For 10 number of measured value, this will be your true value or actual value. And this is for n number of measured value. Now come for the absolute error. So absolute error is basically defined as your true value minus your measured value. So for let's say I want to explain for the x1. For x1 I can write x bar, that is your true value, minus x1 is written as delta x1. This is called absolute error in x1. Similarly, I can write x bar minus x2. This can be written as delta x2. This will be your absolute error in x2. Similarly, x bar minus xn, that will be delta xn. That will be absolute error in xn. The important thing is here that you have to remember that absolute error can be positive, can be 0, can be negative, right? If the average value is more than x1, then you will get a positive value. If the average value is less than, let's say, x5 or x6, you will get a negative value. If the average value is matching with some x5 or x7, then you will tell that the absolute error will be 0 for the x7. Clear? We'll do one example, then it will be clear to you. Got it? Now we'll see mean absolute error. So mean absolute error basically defined as you add all the absolute error divided by n. That is your mean absolute error. So this is, I can write here, delta x bar. So it is delta x bar is your mean absolute error, that is equal to delta x1. I put mod here because I want positive everything, because absolute error is positive and negative and 0, but here I want mean absolute error as a positive, so I'll put mod everywhere. So I'll get a positive number plus delta xn divided by n, right? So this is your mean absolute error. Now we can define relative error or fractional error. So relative error or fractional error is basically defined as your mean absolute error, mean absolute error divided by true value. So mean absolute error divided by true value. This is your relative error or fractional error. So this can be written as, how you can write, this will be delta x bar divided by x bar, right? True value. Now percentage relative error can be written as delta x bar divided by x bar into 100. Clear? Delta x bar divided by x bar into 100 is your percentage relative error. You should remember this thing, will apply and will solve some problem. Now solve this problem. It is NEET 2020 question. So time interval measured by a clock given the following readings. So all are measured value, right? 1.25, 1.24, all are measured value. So what is the percentage relative error? You have to find out. So first find out the true value. What will be the true value? Here you will tell that the true value x bar can be written as 1.25 plus 1.24 plus 1.27 plus 1.21 plus 1.28 divided by 1, 2, 3, 4, 5. 5 numbers are there, you divided by 5. So if you calculate this one, how much it is? 1.25. We can make it to 1.25 by taking from 1.271, 0.01. So to 1.25, then this will be 1.25 and this will be again 1.25 and this will be again 1.25. If you calculate here, so this is actually coming as 6.25. 6.25 divided by 5. Again the value is coming 1.25 second. Clear? This is your 1.25 second. This is your true value, right? 1.25 second is your true value. Now I have to find out the absolute error. So what will be absolute error? That I am writing delta x1, how much it will be? 1.25 minus 1.25, that will be 0. What will be delta x2? Absolute error in x2, that will be 0.01. So I am putting directly mod because I have to find out the mean absolute error, right? So for mean absolute error, we have seen that I have to put mod here. If you can remember, I can show you here. I am putting mod here, right? This formula you can see. First one. So it is here I am putting mod everywhere, right? So I'll put directly mod and find out. If this question is asking how much that absolute error, you can find out without putting the mod. What will be delta x3? Delta x3 will be, you will tell that this will be 1.27, so this will be 0.02. What will be delta x4? That will be 0.04. What will be delta x5? That will be 0.03. Right? So all this your absolute error you got. Right? So now I want to find out the mean absolute error, that is delta x bar. So that will be 0 plus 0.01 plus 0.02 plus 0.04 plus 0.03 divided by here 1, 2, 3, 4, 5, right? Divided by 5. So how much it is basically coming, you can check here. This will be 0.1, this will be 3, this will be 7. So it is coming 0.1 divided by 5. So 0.1 divided by 5, you can say that this will be 0.1 by 5 will be 0.2 divided by 10. So this will be 0.02. So this one is your mean absolute error. Now it is easy for me to find out the percentage relative error. First find out the relative error. So relative error is delta x bar divided by x bar. This is your relative error. And percentage relative error, I know that will be delta x bar divided by x bar into 100. This is your percentage relative error, and that is equal to delta x bar you got how much? 0.02 divided by x bar how much you got? 1.25 you got, right? Into 100, right? So if you calculate here, this will be 2 by 1.25, so I can write this will be 200 divided by 125. So by 25 we can cancel out. We'll tell that this will be 8, this will be your 5. So if you calculate here, this will be 1 point, then 30, this is 1.6 percentage, right? 1.6 percentage. So option number D is correct here, right? Everything is clear with this question. You find out the mean value or your true value, then you find out the absolute error. After finding out the absolute error, you find out the delta x bar, that is your mean absolute error. After finding out the mean absolute error, you find out the relative error and you multiply 100, that is percentage relative error, and the answer is 1.6 percentage. Okay. Now we'll see how to do addition in the errors. Let's say I want to add these two, a plus delta a and b plus delta b. So I can write here x is basically your a plus b. Now I want to add these two number or any two physical quantity. Let's say this is length or this is also can be length. We'll see one example, then this will be clear to you, right? So what I can write here, x plus delta x is equal to a plus b plus delta a plus delta b. Here I can put plus minus. Got it? So because delta x basically delta a plus delta b, so you can put here plus minus, like that this b plus minus is there, right? So this is your addition here, like that you can find out. So how it is coming, basically I can show you that x plus minus delta x is basically a plus delta a plus minus delta a plus b plus minus delta b is equal to a plus b. Here I can put plus minus delta a plus delta b. So this is your thing. So delta x is what? Error in x. That will be delta a plus delta b. And final reading is what? Final reading will be your x plus minus delta x. Clear? So we'll take one example. Let's say I am taking length. L1 is the length I am taking. 2 plus minus 0.3 meter here. And L2 I am taking 4 plus minus 0.2 meter. Now I want to add L1 plus L2. So how much it will come? This is L1 plus L2, right? Or total length basically I am talking about. So I can write here total length. So total length will be net length. I will write. So you see here L is equal to that 2 plus 4 plus minus 0.3 plus 0.2 meter, right here. So this will be 6 plus minus 0.5 meter. Clear? So like that you have to add. So the delta A will be added with delta B, right? And A will be added with B. Clear? This is the case. Now we'll see for subtraction. For subtraction, let's say I am writing again x equal to a minus b. So this can be written as x plus minus delta x is equal to a minus b plus minus delta a plus delta b. You should remember here you have to put plus, not minus, because you are maximizing error. So I can say that maximize error by putting a plus sign here. And we have discussed in the class, right, why it is you are putting basically plus sign. So that thing we are not going to discuss here. You should remember that whenever there is also a minus, you should not put minus in the error. You should always put plus here. Clear? So delta x, basically here it will be delta A plus delta B. Or you can remember one thing, that errors is additive. You will add. There is no subtraction of error. You always add the errors. Right? This is your A. In A, error is delta A. In B, error is delta B. You are adding, either you add A plus B or you subtract A minus B. Always this delta A plus delta B will be there. Not delta A minus delta B will be there. Clear? Delta A minus delta B is not there. Only delta A plus delta B is there. You just remember that thing. Right? So similarly, I can take for subtraction one example. So length equal to, let's say, 5 plus minus 0.6 meter, and L2 is equal to 2 plus minus 0.4, or I can take 0.1 meter. So if I subtract here, how much it will come? Obviously you will tell L equal to 5 minus 2, that is A minus B, you see here, plus minus, I have to add here 0.6 plus 0.1, total meter, right? So this will be 3 plus minus 0.7 meter. This thing you have to remember, right? Errors are always additive. Okay, this is the subtraction how you have to do. Now we'll see some basic thing here, then we'll go for the multiplication and division. So basically, first of all, I will tell about little bit log function, right? So there is logarithmic function. So in the logarithmic function, there is basically two types of logarithm is there. One is your log, another one is ln. So whenever I am writing log, I have to put a base here 10. This is your base. And whenever I am writing ln, I will put base as a e. This is called your base. Right? So let's say here I am telling y equal to log x. So I am here, the base is 10. This can be written only log of x. Whenever log of x, you should remember that the base is 10. Similarly, if they tell y equal to ln x, you should remember the base is e here. That is ln of x you can write. This should be ln of x. This should be your ln of x. So this is your ln x. So the base is e. That will be ln x. I can write like that. Whenever ln will come, you should remember that there is a base is e, and wherever the log will come, you should remember the base is 10. Right? And these are log is basically called your common logarithm, and this ln is called your natural logarithm. Right? Ln is called your natural logarithm. All these things you will study in math. Okay. Now I'll tell some property, that thing you have to remember. Some property you have to remember. That is, first one is, if I write log x to the power a, it should be log of a you take outside, and this should be log of x, right? Similarly for ln x to the power a, that means a ln x. Second thing, if log a into b is there, you can say that this will be log of a plus log of b. Third one, log of a divided by b is there, then you can say that log of a minus log of b, right? And fourth one is, this is also true for the ln a by b will be a divided by b will be ln a minus ln b, right? All this thing property will be hold for the ln, only the base is different here. Here base 10, here base e. So if I write y equal to log 10x, this can be written as 10 to the power y equal to x. Similarly, if I write y equal to ln ex, base is e, this can be written e to the power y equal to x. Like that we can write. Clear? So these are the few properties you have to remember, right? First thing, if there is a power, you just see here, if there is a power, first formula, then you can take that power outside and this will be log of x. Similarly for the ln also. Clear? These things are important. Now one more thing, we are going to see that derivatives. So here we need only 2 or 3 formula, that's it, and we can solve this errors problem. So first of all, derivative of constant is basically 0. Derivative means you are writing d by dx here, right? Or differentiation also it is called. And derivative of log x will be your 1 by x. Clear? Now another thing is that if I write derivative of log of x to the power a, this can be written as derivative of a into log x. So a, if is a constant, I can take it to outside and this will be d by dx of log x. Clear? This way you can find out the derivative of log x to the power a. And here it will be a by x. So derivative, that is d by dx of log x, is basically 1 by x. I can write derivative of d of log x equal to dx by x, or this derivative of log x I can write as delta x by x. This thing we are going to here, dx or delta x we can write, and we are using this one. Clear? If there will be derivative of log of x to the power a is there, then what it will happen, this will be a delta x divided by x. This it will come. Okay, now let's go to the next slide and we'll solve some problem depending on this formula. So now we are going to see the multiplication here. For multiplication, let's say I want to multiply a and b. So x equal to basically a into b. So I put ln x equal to ln a into b. By property you can say that this is ln a plus ln b. So ln x, that is your dx by x. I am doing the derivative here. Ln x derivative will be dx by dx. So you see here, we have written here, right? This thing dx by dx. Clear? Is equal to, here This can be written as dA divided by A plus dB divided by B. So what you do here, I can write this one is delta x by x mod. I will put a mod here because I want positive always, right? Delta A by A mod. Similarly, here it is delta B by B mod. Clear? So you should remember that this delta A and delta B always are positive, so that I will put the mod here. And I told error is always additive, right? So this delta x by x is called is what? Fractional error or relative error. Fractional error in x, right? Similarly, this one is called what? Fractional error in A. This one is called what? Fractional error in B. Clear? So if I multiply 100 here, this is going to be your percentage fractional error, right? Or percentage relative error. So, or percentage error also we called. So I can write delta x by x into 100 is equal to delta A by A mod. If I put here, I'll put mod everywhere, 100 plus delta B by B mod into 100, right? So this full term is what? This is your percentage error in x. This is percentage error in x. So this will percentage error in A. This is percentage error in B. Like that you can find out. Okay. Percentage error or relative percentage error you can tell also. Now do this problem. The length and breadth of a rectangle are, so length they have given 5.0 plus minus 0.1 and breadth they have given 4.0 plus minus 0.2. Calculate the area of the rectangle with error limit. So area is what? L into B. So you have to find out the area here. So what you will tell here? You just see the formula here. So like that you have to write, right? So I am directly using this formula. I can write delta A by A is equal to delta L by L plus delta B by B, and I will put mod everywhere. Got it? I am not writing ln and all these thing. Log ln I am not using like that we did here. I put ln and do all this thing. I am not doing all this thing. I am directly writing. Okay. So this is delta A by A equal to delta L by L plus delta B by B. So delta A by A mod is equal to delta L by L, that is delta L is what? 0.1 divided by 5 mod plus delta B by 0.2 divided by 4 mod. Clear? So delta A will be how much? 0.1 divided by 5 plus 0.2 divided by 4 into A. What is the area value? Area equal to L into B, that will be 5 into 4, that will be 20 centimeter square. So everything in centimeter, I am not writing all this thing, centimeter again. So this will be 0.1 divided by 5 plus 0.2 divided by 4 into area you got 20. So if you got 20 here, this will be 4, this will be 0.4 plus this will be 5, this will be 1. You can say that this will be, sorry, this should be 20 into this much, na? So it should be 1 by 2 and 1 by 20, so it should be 1. Here it should be 1. right? So how much you are getting? This will be 1.4. So delta A you are getting 1.4. So what will be the reading then? Area. So area, total area, that can be written as A plus minus delta A, that is equal to A is your 20, that will be plus minus here 1.4 you got, right? This will be centimeter square. Clear? Like that you can find out. Now we'll see for the division. Similarly for division, if you see that I am writing x equal to a by b basically, right? Again I can put ln x equal to ln a minus ln b. So doing the derivative, this will come as delta x by x equal to delta a by a minus delta b by b, right? But I want maximum error. So what I have to do here, I'll put a positive sign here. I want maximum error. So I can say here for maximum error, I have to put a positive sign. So I'll write delta x by x mod is equal to delta a by a mod plus delta b by b mod. So this should be your formula. You should not write the negative sign. Got it? So this is called your what? Relative error. Like previously we have seen. Relative errors. Got it? If you multiply 100 here, that will be percentage error. So this will be delta x by x into 100 if you do is equal to delta a by a mod into 100 plus delta b by b into 100. So this is going to be your into 100. So just a minute. It's so plus delta b by b into 100, right? So this is your relative error, percentage relative error or percentage error you can say. This way you can find out this one. This is for percentage error. Now we can do this problem. In an experiment, mass of object is measured by applying a the known force. So in an experiment, mass of an object is measured by applying a known force on it and then measuring its acceleration. If in the experiment the measured value of applied force and measured acceleration are F they have given, A they have given, they are asking for the mass. So mass, you know that F by A, right? So I can write delta M by M is equal to delta F by F plus delta A by A. Clear? I am directly writing all these things. So you can put mod here or you can write positive sign in between them. So mass will be how much? Mass will be F by A. F is how much? 10 divided by A is 1. That should be 10 here. So delta M is equal to delta F by F, that is 0.2 divided by 10 plus delta A by A. This is 0.01 divided by 1, right? Into this mass here. I am taking the mass here, right? So it should be 10 here. So if you put this value, how much you will get? This will be 0.2 plus this will be 0.1. You will get 0.3. So delta M you get 0.3 kg. Everything is in SI unit, so it will come as kg. If this delta M is in kg, Now I want to find out the mass. So mass will be the total mass I am writing. So total mass or the reading, or you can say that the mass whichever you are going to read, because in that mass there should be some error will be there. So mass that you are reading is equal to m plus minus delta m, right? Like force is F plus minus delta F. So here it is mass reading will be m plus minus delta m, and m value you got 10. This will be plus minus 0.3, or you can write this will be 10.0. This will be basically this will be basically 10.0 plus minus 0.3 whole kg. So you check which option. So option number C will be correct, right? Now go for the next one. Now if the polynomial is there, so what you will do for the polynomial? Obviously for this one you apply ln. So ln r equal to ln x to the power a, y to the power b, z to the power c. So ln r equal to ln x to the power a plus ln y to the power b plus ln z to the power c. So this is a ln x plus b ln y plus c ln z. That will be ln r. So if you do derivative, this will come as delta r by r. This will be a delta x by x. Put the mod here everywhere, right? Because I want to maximize the error. B into so you put the mod like this. Just see here. You want to maximize the error, so you have to put the mod like, you should include the mod inside the a also. Delta x by x plus b delta y by y plus c delta z by z mod, right? This is the case you will get. This is what? This is your basically relative errors. This is due to the relative errors. Now if someone will ask what should be the percentage error, you simply multiply 100 here, right? That will be going to your percentage error. So here I can write here. So this will be delta r by r into 100 a into delta x by x into 100 plus b into delta y by y mod into 100 plus c into delta z by z into 100, right? Sorry, so this should be plus 100 plus c delta z by z mod into 100. Clear? So this is your percentage relative error or percentage error if the polynomial is like that. Similarly, if the polynomial is like this, I am directly writing this formula. So this will be delta r by r mod equal to, here you see, this will be a into delta x by x mod plus b into delta y by y mod plus c into delta z by z mod plus d into delta t by t mod. You should not put the negative sign, right? So this should be your relative error. And percentage error, you know how to find out. This is your relative or fractional error. So percentage error, you have to multiply the 100 everywhere, right? Okay, now let's go to the question. So in an experiment, four quantities A, B, C and D are measured with percentage error 1%, 2%, 3%, 4% respectively. The quantity P calculated as, so P basically AQ B square by CD. So delta P by P, I can write this will be 3 into delta A by A mod plus 2 into delta B by B mod plus delta C by C mod plus delta D by D mod. Clear? So they are asking percentage error. So you multiply everywhere 100. So this side it will be delta P by P into 100, that is your percentage error in P. This full term is percentage error in P is equal to 3 into delta A by A mod into 100 plus 2 into delta B by B mod into 100 plus delta C by C mod into 100 plus delta D by D mod into 100. So delta A by A into 100, that will be percentage error for the A. So this will be 3 into 1 percentage plus this will be 2 into delta B by B, that will be 2 percentage plus delta C by C, that will be given 3 percentage plus delta D by D they have given, this is 4 percentage. So if you calculate how much it is coming, 3 plus 4 plus 3 plus 4, right? 4 plus 4 8, this will be 3 plus 3 6, so 8 plus 6, so it is coming 14 percentage. Clear? This is coming 14 percentage. So option A will be your correct option. Now go to the next question. So this question also you can do, right? So they have given A, B, C, D error. You have to find out the error in X, percentage error. So delta X by X into 100, I am directly writing, is equal to what? 2 into delta A by A into 100. So that will be how much they have given? 1. So this will be 2 into 1 percentage plus half into delta B by B into 100. They have given, this will be 2 percentage plus 1 by 3 into delta C by 3. They have given 3 percentage plus 3 into delta D by D, that will be 4 percentage. This is the case. So this will be 2 plus 1 plus 1 plus 12. Got it? So this will be 4 plus 12, that will be your 16 percentage. So this will be option number 3 will be correct. Got it? I did it directly because just now we did this question, right? Just now we did this for this question. So I did there directly. Now go for this question. A metal wire has mass, they have given the mass, radius they have given, and length they have given. The maximum possible error, percentage error in the measurement of density. What is density? You know, mass by volume. So this should be mass divided by area into length, right? And area basically written as mass by pi r square into L, right? So you should remember this constant, right? Pi is a constant. This won't play any important role for the errors. So I can write delta rho by rho is equal to delta m by m plus delta L by L plus 2 into delta R by R, and I can put mod everywhere, right? And they are asking percentage, so I will multiply 100. So delta rho by rho into 100 will be what? Delta m by m into 100, that is, you can find out here, delta m is how much? 0.002 divided by m is 0.4 into 100 plus delta L by L, that will be 0.02 divided 5 into 100, because you see here it's also centimeter the length, and delta L also centimeter. You don't have to convert the units here, right? Plus 2 into delta R, how much? 0.001 divided by 0.3 into 100. So this one I can write here. So I am writing this delta R here, plus here I write 2 into delta R is your 0.001 divided by your 0.3 into 100. This is the case, right? So how much this value will come? Obviously this will be 0.2 by 4, 0.4, that will be 2 by 4, plus this is coming 2 divided by 5, plus this is around this is 0.1 by 3, so it will be 2 by 3, right? So this is coming, so you can tell that this will be this one you can make, na? This should be 2 by 4, you can write 1 by 2. Let's write it is 1 by 2 here. Then it will be easy. So 2 by 4 I am writing 1 by 2. This should be 1 by 2. And then this will be 30 will come as your LHS for this one. And this should be 15. And this should be your 12. This should be your 20. So it is coming around 32 plus 15, right? 47 by 30, right? So 47 by 30 you can calculate. This will be 4.7 by 3, right? 4.7 by 3 will be how much? So you can put first 1. This will be 1 point. So it is basically near about 16. So it will be 1.6 then. So near about 1.6. So near about 1.6. Sorry. So this is near about 1.6. So 3 divided by this one, this will be 1.6, near about 1.6. So less than 1.6, that is 1.5 something it will come. So this will be 1.6. So option number 2 will be correct, right? So exact value if you find out, it's coming 1.566. So you can write this is 1.6. Clear? So this is your correct answer, the option number 2. Let's go to the next question. The percentage error in the measurement of mass and speed are 2%, 3% respectively. The error in the estimates of kinetic energy, right? So kinetic energy percentage error they are asking, because in answer they have put percentage. So kinetic energy we can write that is equal to half mv square, right? So kinetic energy equal to half mv square. So what I can write here, delta ke divided by ke is equal to delta m by m, because half is a constant. I won't take that one, it will get cancelled out. This will be 2 delta v by v, right? Why it will get cancelled out? Because ln half, if you put ln both sides, this ln half is a constant quantity and ln half derivative will be 0 basically, because constant derivative is 0. 2 delta v by v. So if someone has to find out, if I have to find out the percentage, I will multiply 100. So this will be delta ke divided by ke into 100 is equal to delta m by m into 100, that they have given. Mass is 2 percentage, so 2 percentage plus 2 into speed is your 3 percentage, so this will be 3 percentage. So this will be 6 plus 2, that will be 8 percentage. So which one will be correct? Option number D will be correct. Now in an electrical circuit, voltage is measured as V equal to 200 plus minus 4 volt, and the current is measured as 20 plus minus 0.2 ampere, the value of resistance. So it's very easy, right? So first of all you find out the resistance. So resistance will be what? V by I. So V is what? 200 divided by I is 20. So it should be 10. So 10 ohm is your resistance, but I want to the reading value, right? So there will be some plus minus delta R plus minus delta R. For that what I have to do, I can write delta R by R from here. Here this formula I am using, delta R by R equal to delta V by V plus delta I by I. Clear? And delta R can be written as delta V by V plus delta I by I into R. What is delta V by V? So delta V is basically 4 divided by 200 plus delta I is equal to 0.2 divided by 20 into R is how much you got here? 10. You multiply by 10. So if you calculate here, this will be 4 by 20 plus 1 by 10, right? So this is coming as 3 by 10, that will be 0.3, right? So which option it will be correct? The reading will be R plus minus delta R. So this is your delta R. So reading will be R plus minus delta R. So R is your 10. So R is your, what you got, R value is your, here it is 10 ohm. So you put 10 ohm plus minus delta R is your 0.3, right? So this is your answer, 10 plus minus 0.3 ohm, right? So which option it will be? Option number 2 is correct. So this question actually asked this time only, NEET 2024. So all the question we are doing the previous year question, you can see, and this exactly this type of question they ask in the JEE mains this year only. And they only ask the percentage error in the resistance. They won't ask the full reading. They ask only the percentage error. You can check that question also. A students measure the distance traveled in free fall of a body initially at rest in a given time. He uses his data to estimate the g, the acceleration due to gravity. If maximum percentage error in the measurement of distance and time. So distance, let's say I'm writing h. So percentage error they are telling delta h by h into 100, that is your E1. Similarly they are telling that in time delta t by t into 100, that is your E2. Clear? They have given this one, right? E1 and E2. If you see here, this is E1 they have given, and here they have given E2. Now percentage error of G you know. So what you know that formula, right? T equal to what? 2h by g for free fall, right? Root over. So from here you can say that g equal to 2h by t square. So 2 is a constant, it won't contribute anything. So delta g by g equal to delta h by h plus 2 into delta t by t. So everywhere we will put the mod here, right? And percentage error they have given, so you multiply 100. So delta g by g into 100, that is percentage error in the g, that will be delta h by h into 100, that will you will get E1 plus 2 into delta t by t into 100 is your E2. So this is your E1 plus 2 E2 equal to delta g by g into 100, right? So which option it is coming? Percentage error in the g. So this will be E1 plus 2 E2. So option number B will be your correct. Now go to the next question. To find the spring constant K of a spring experimentally, a student commits 2% positive error in the measurement of time and 1% negative error in measurement of mass. So I have to write down the formula first. So time period equal to 2 pi m by k root over, right? So I want to find out k. So k will be basically 4 pi square m divided by t square. So delta k by k, because I have to percentage error. 4 pi square is a constant quantity, it won't contribute to the error because ln of 4 pi square derivative will be going to 0. So it should be delta m by m plus 2 delta t by t, and you can put the mod everywhere, right? So they are telling about the percentage, so you multiply everywhere 100. So delta k by k into 100, that is percentage error in kinetic energy, that is delta m by m into 100, that is they have given student 2% positive error in the time and 1% negative error in the mass. So you have to put here 1%, that should be 1 plus, sorry, this should be 1 plus 2 into delta t by t. So delta t by t into 100, how much it is? 2 percentage positive error in the measurement of time. So this will be 2 percentage. This is 1%, this is 2. 4 plus 1, right? So this will be 1 plus 4, that will be 5 percentage, right? So delta k by k has 5 percentage error. So option number 4 will be your correct. Now go to the next question. So radius, length and resistance of a metal were given. This all are given. The percentage error in the resistivity. So you know that rho equal to RA by L. So R into pi R square. Area will be pi R square divided by L. So delta rho by rho is equal to what? Delta R by R plus mod you can put, right? So 2 delta R by R radius plus delta L by L. If they are asking about percentage, you multiply 100 everywhere. So delta rho by rho into 100 is equal to what? Delta R by R into 100. So delta R how much? 10 divided by 100 into 100 plus. Then 2 into delta R by R. So 2 into delta R is your 0.05 divided by 0.35 into 100 plus delta L is given 0.2 divided by 15 into 100. Okay, so what is the value here? It is coming 100 cancel out, 10 plus this will be you can see here this will be 1 by 7, right? So 200 by 7 here. This will be 10. Oh, sorry. Yes. So this would be 10 and 2 into delta 2 into 0.05 divided by 0.35, right? So it will be 200 by 7 plus this is coming as 20 divided by 15. So if you calculate all these things, how much it is coming? So this is your 10. I can write this is your 10 plus 200 by 7 around 28.5 plus 20 by 15. So it will be around 20 by 15, so it will be 4 by 3. So it will be 1.33 obviously. 1.33. So if you calculate, this will be 38, 39 and 39.83, right? So this is coming as 39.83, right? So it's coming around which option it is matching, best matching. So option number 2, right? So it is matching best. So basically 200 by if you do 7, so it is coming to do 28.57. So if you write 57 here, it will be then 9. Obviously it will come 9. So you can write here, or you can approximate and you can get the value. This will be obviously 39.9 percentage. So you will get option number 2 clearly. Okay, The next question. If the percentage error in the measuring of length and diameter of a wire is 0.1%, then the percentage error of the resistance. So what is resistance? Resistance equal to rho L by A. So resistivity is constant here. So delta R by R you can write here. Before that I just modify it. Rho L divided by area can be written as pi R square. So delta R by R will be delta L by L plus 2 into delta R by R. Pi is a constant, it won't include for the errors, right? And they have given percentage. So multiply 100 here, multiply 100 here. If you multiply 100, this will be delta R by R into 100 equal to delta L by L into 100 is 0.1 percentage plus 2 into 0.1 percentage. So this will be 0.3 percentage you are getting. So which one? Option number 1 will be correct. Then a physical quantity Q found to be depend on quantities A, B, C by relation. This question you can do, right? So how much it will come? Delta Q by Q into 100 is equal to 4 into delta A by A into 100 plus 3 into delta B by B into 100 plus 2 into delta C by C into 100. Now you can calculate this one, right? So for A this is 3%, 4 into 3 plus 3 into 4 plus 2 into, for C it is 5. So this will be 12 percentage. You can write percentage everywhere. 12 percentage plus 12 percentage plus 10 percentage. So this will be 24 plus 10, 34 percentage. So which option will be correct? This one, right? Now go to the next question. Two resistance are given as R1 is given, R2 is given. They are connected in parallel. So parallel case I just discuss here, then we'll do this question. So if this type of arrangement is there, let's say 1 by x equal to 1 by a plus 1 by b. For this case what you have to do here, if you do derivative of d by dx of x to the power n, x to the power n equal to n into x to the power n minus 1. So derivative of x to the power minus 1 will be minus 1 divided by x square, right? And d of x to the power minus 1 can be written as dx minus dx divided by x square. Clear? So now we can put here this value, all the value I can put. So delta x by x square, because I put mod here, I don't include the minus sign. So this will be delta a by a square plus delta b by b square, mod everywhere. Got it? This formula we can get. And if relative error they ask, delta x by x, because delta x by x is relative error, so this should be delta a by a square mod plus delta b by b square mod into, that is x. This is your relative error or fractional error for x. Clear? So with using this formula we will calculate now. You got it, right? 1 by x equal to, because resistance in parallel, this formula it hold, right? 1 by r equivalent equal to 1 by r1 plus 1 by r2. Now see here, r1 given, r2 given. Now they are asking the percentage error in measurement of equivalent resistance. So what I can write here, 1 by r equivalent is equal to 1 by r1 plus 1 by r2. So what will be the r equivalent? Obviously you know that this will be 15 into 10 divided by 15 plus 10. So it will be coming around 150 divided by 25. So if you calculate this one, so this will be 6, right? So 6 is the R equivalent. So now I am doing the derivative of this equation. So delta R equivalent divided by R equivalent square equal to delta R1 divided by R1 square plus delta R2 divided by R2 square. So delta R equivalent divided by R equivalent, this is your relative error, and if you multiply 100 here, this will be delta R1 divided by R1 square into 100 plus delta R2 divided by R2 square into 100 into R equivalent, because R equivalent square is there, right? And everyone you can put mod here. Here it will be mod, or you can take the positive value. If you are taking positive value, then you don't have to put the mod. So see here, what will be delta R1 by R1 square? This will be 0.5 into 100 divided by 100 plus this is 0.5 divided by 15 square into 100. All are multiplied by 6, R equivalent equal to 6. How much it is coming? You just see 100 cancel out. 6 into 5, this will be 3. Here it is 3 plus, so it will be 6. 15 square is there, so we can say that this is coming around 0.5. So here I am calculating that one. So this will be 0.5 into 100 divided by 15 into 15. 15 into 15 into 6, right? So this will be your 2, this will be your 2, this will be your 5, and this will get cancelled out, 10 to the power minus 1, and here it will be 10 only. So 20 divided by 15. So 20 divided by 15, you know that is 1.33. That thing, same type of problem we did now. So this will be 1.33. So if you calculate, this will be 4.33. The result will be 4.33. So option number 3 will be correct. Okay, so this one we have seen. Now do this question. A torque meter is calibrated to reference standards of mass, length and time with 5% accuracy. So everyone has 5% accuracy. After calibration, the measured torque with this torque meter will have net accuracy of. So torque basically can be written as M1 L2 T minus 2, right? Dimension we can write like that. So from here I am trying to write down delta tau by delta tau. This is basically torque, right? This is basically torque. Delta tau by delta tau, I can write delta M by M plus 2 into delta L by L. You can put the mod here, you can write down positive value here. Anything you can do. So delta M by M, 2 delta L by plus 2 into delta T by T mod. They are asking percentage, you multiply everywhere 100. So delta Z by Z into 100, that will be your percentage error in the torque, right? Sorry, it's not delta Z, sorry. This is not delta Z, this is tau, right? Torque. So this would be delta tau divided by tau into 100, that is percentage error in the torque. Delta M by M into 100, it is 5% accuracy, 5% plus 2 into delta L by L, 5% accuracy, 5 plus 2 into delta T by T, 5% accuracy, 5. So this will be 10, 10, 20, 25 percentage, right? 25 percentage you will get. So option number B will be your correct option. So all are percentage here. This is 5% and this is 5% and this is 5% as given in the question. So 25% is your correct answer. Now the maximum error measured in the resistance, current and time for which the current flow in a electrical circuit are 1%, 2% and 3% respectively. The maximum percentage error in the detection of the heat dissipated. So heat dissipated you know. So H equal to what? I square RT, right? So delta H by H into 100 is equal to 2 into delta I by I into 100 plus delta R by R into 100 plus delta T by T into 100, right? So here you can say that current how much? Current is your 2 percentage. Current is 2 percentage. So 2 into 2 percentage plus delta R by R. So here the resistance is 1 percentage. So this will be 1 percentage plus delta T by T. So time is 3 percentage basically. So this will be 3 percentage. So if you calculate here, this will be 4 plus 1 plus 3. This will be 8 percentage. So option number D will be correct. Right? There will be percentage error in the heat dissipated will be 8 percentage. Now this is the last question. We will see and stop. If the force acting on a body of mass 2 kg plus minus 20 gram. So mass they have given 2 kg plus minus 20 grams. So you have to be very careful because these two units are not same. This is in kg, this is in gram. And force they have given, that force value they have given actually, force reading value they have given 3 Newton plus minus 2 percentage. So they have given this one is 2 percentage. 2 percentage means what? This is delta F by F into 100. That is your 2 percentage. Clear? Now they are asking percentage error in the acceleration. So acceleration is what? F by m. So delta A by A into 100 is equal to delta F by F into 100 plus delta m by m into 100. All value you can put the mod here. This value you can put the mod here. Right? You can put the mod here. So what is delta F by F into 100? That will be 2 percentage plus delta m by m, that is 20 into 10 to the power minus 3 kg divided by 2 kg because I have to convert the gram to kg, right? Into 100. So this is 2 plus, and you can say that this is going to change. This will be 1 percentage basically. This is 2 percentage, this is 1 percentage. So it is coming as 3 percentage. So option A will be your correct option.